For the last 20 years, this standard silicon panel attached to your roof has been hailed as the ultimate and only path to energy independence. But the reality is, modern technology has drastically changed what's possible with rooftop solar, and the systems you can run in your own home right now are nothing short of remarkable. In this video, I'm going to share 5 radical solar innovations that represent the absolute cutting edge of domestic power technology that you can utilize in your own setup right now to help achieve energy independence. And these are not experimental prototypes locked away in a university lab either. They are all commercially available, with each one designed to overcome the biggest, most frustrating problems in small-scale energy generation. So let's jump in and see what is on offer. First on our list is the naked Energy Virtu. One of the greatest, yet least discussed, flaws of standard photovoltaic solar panels is their relationship with heat. It is a massive paradox in the solar industry. Panels require intense sunlight to generate maximum electrical power, but the hotter the physical silicon gets, the less efficient it becomes. For every degree a standard solar panel rises above 77 degrees Fahrenheit, it loses a measurable percentage of its ability to convert photons into electricity, a metric known as the thermal coefficient. On a blistering summer day in the American Southwest, a dark roof can easily exceed 150 degrees. Right when the sun is at its absolute brightest and most abundant, traditional solar panels are practically choking on the heat, bleeding massive amounts of potential power into the surrounding air. Simultaneously, the average American home is burning immense amounts of natural gas or drawing huge amounts of grid electricity just to heat water for showers, dishwashers, and laundry. The Virtu system, engineered by Naked Energy, solves both of these massive inefficiencies by combining 2 completely different technologies into a single, breathtaking piece of architectural glass. It is a photovoltaic thermal panel, or PVT for short. But unlike early clumsy attempts at PVT, the Virtu utilizes highly advanced evacuated glass tube technology. Instead of a flat, exposed board, the Virtu system features a sleek array of cylindrical glass vacuum tubes. Inside each heavy-duty borosilicate glass tube sits a high-efficiency, monocrystalline solar cell. Because a vacuum contains no air molecules to transfer heat, the glass tube acts like an absolute thermal fortress, a high-tech thermos that traps the sun's raw thermal radiation inside while letting the photons pass through to hit the silicon. As the solar cell generates electricity, it naturally begins to heat up. But instead of letting that heat degrade the electrical output, the Virtu system integrates a precision-engineered liquid manifold directly beneath the cell. A specialized glycol fluid is pumped through this channel, actively stripping the extreme heat away from the silicon. This acts as a highly efficient liquid cooling system, keeping the photovoltaic cell operating at its absolute peak electrical efficiency even in the dead of summer. But that captured heat doesn't just dissipate, it is pumped directly into your home's hot water cylinder. The sheer thermal density achieved inside that vacuum tube allows the system to generate zero-carbon hot water up to roughly 175 degrees Fahrenheit. Financially and spatially, this completely alters the math of a domestic installation. Roof space on a standard American home is highly limited. Normally, you have to choose between covering your roof with electrical solar panels or dedicating that precious square footage to bulky solar water heaters. The Virtu system delivers both utilities from the exact same footprint. While the upfront hardware cost sits higher than standard panels, often ranging between $300 and $400 per tube assembly, the dual utility payback period is astonishing. By simultaneously slashing your electrical bill and completely zeroing out the natural gas or electrical draw required to heat your home's water, the Naked Energy Virtu turns the worst enemy of solar power, extreme heat, into a highly valuable domestic asset. Alright, up next is the EcoFlow STREAM Ultra. To truly understand the next innovation, you have to understand why residential solar is so incredibly expensive in the United States. If you buy a raw solar panel off a warehouse shelf today, the physical hardware is staggeringly cheap, often less than 50 cents per watt. The silicon itself is no longer the financial barrier. The reason a standard home solar installation costs $30,000 is due to what the industry calls soft costs. When you install a traditional grid-tied solar system, you are paying for the labyrinth of bureaucracy. You are paying thousands of dollars for a certified master electrician to rip into your home's main breaker panel. You are paying for costly city building permits, complex zoning inspections, and the heavy, wall-mounted string inverters required to safely interact with the multi-billion-dollar utility grid. And if the grid goes down during a storm, standard solar panels automatically shut off to prevent backfeeding power to the lines, leaving you sitting in the dark despite having a roof full of power. The EcoFlow STREAM Ultra completely rejects this centralized, bureaucratic model of energy. It is a highly compact, hyper-minimalist, plug-and-play solar and storage system designed to completely bypass the electrician, the permitting office, and the utility company's approval process. The physical architecture of the STREAM Ultra is an exercise in extreme integration. It looks less like a piece of heavy industrial equipment and more like a sleek, modern household appliance. Inside its minimalist casing, it houses a state-of-the-art lithium iron phosphate, or LiFePO4, battery bank, a sophisticated maximum power point tracking charge controller, and, most importantly, a highly advanced microinverter. In engineering, complexity is the absolute enemy of self-sufficiency. Historically, wiring up a system that could seamlessly switch between solar charging, battery storage, and home powering required a massive plywood board in your garage covered in dangerous, high-voltage direct current wiring, external rectifiers, and heavy copper lugs. The STREAM Ultra miniaturizes all of that infrastructure. You simply take standard, commercially available solar panels, place them in your backyard, on a ground mount, or on an awning, and click their standard MC4 cables directly into the back of the EcoFlow unit. But the true disruption lies in how it delivers that power to your home. You do not need to wire this into your main breaker panel. The STREAM Ultra features the ability to plug directly into a standard American NEMA 15 or NEMA 20 wall outlet. Using highly advanced, synchronized microinverter technology, the unit analyzes the exact alternating current sine wave of your home's existing electrical grid. Once it perfectly matches the frequency, it pushes the stored solar energy directly back through your wall outlet, instantly powering the appliances on that specific circuit and trickling power into your home to reduce your utility draw in real time. Financially, this system represents the ultimate modular approach to energy independence. A base unit typically starts around the $2,000 to $3,000 mark, depending on the battery capacity you select. But because there are absolutely zero installation costs, no contractor markups, and no non-refundable permit fees, every single dollar you spend goes directly into raw energy generation and storage. It also completely solves the blackout problem. If the centralized grid fails, the STREAM Ultra instantly acts as an autonomous off-grid generator, utilizing its internal batteries and the sun to keep your refrigerators, medical equipment, and communication devices running continuously. It proves that establishing a robust domestic microgrid does not require a second mortgage or a fleet of contractor vans in your driveway. It simply requires brilliantly integrated plug-and-play electronics. At number 3 is the GAF Timberline Solar. The entire residential solar industry harbors a massive, structural secret. Traditional panels are inherently destructive to the building they are meant to power. When a standard array is installed on a home, a specialized solar contractor must drill dozens, sometimes hundreds, of thick steel lag bolts directly through the weatherproofing of your roof and deep into the structural wooden rafters. They then mount heavy aluminum rails to those bolts, suspending the glass panels a few inches above the shingles. Every single one of those penetrations is a potential leak, relying entirely on rubber gaskets and chemical sealants to keep the rain out of your attic for the next 2 decades. But beyond the threat of water damage, this racking system creates what the industry calls the roof replacement trap. If a homeowner wants to install solar, but their existing asphalt roof is already 10 years old, they face a financial nightmare. If they install the panels now, in 5 to 10 years when the old shingles begin to fail, they will have to pay thousands of dollars to a solar crew to completely dismantle and remove the entire array, pay a roofer to replace the shingles, and then pay the solar crew again to reinstall the panels. To avoid this, you are usually forced to prematurely replace your entire roof before you ever buy the solar system, destroying the financial return on investment. GAF Energy's Timberline solar system completely shatters this trap by fundamentally redefining what a solar panel is. It rejects the idea that solar is an electronic appliance bolted onto a house, and instead treats it as a primary building material. And visually, it looks very different from your average PV array. If you walk onto a Timberline job site, you will not see specialized electrical engineers carefully hoisting heavy glass rectangles onto steel rails. Instead, you will see a standard local roofing crew using standard pneumatic nail guns to shoot galvanized nails directly through the top edge of the solar panel itself. This is possible because the Timberline system is not just a solar panel. It is the first true nailable solar shingle. It is the only solar product in the world formally certified as a primary, water-shedding roofing material. The photovoltaic cells are laminated into a highly durable, flexible architectural shingle that rolls out and lays absolutely flush against the roof decking. There are no gaps for wind to catch, no heavy aluminum frames, and no lag bolts penetrating your waterproofing. The engineering brilliance here lies in the installation mechanism. Traditional building, integrated photovoltaics, like Tesla's highly publicized solar roof, are notoriously complex. They require highly specialized, expensive crews who must carefully wire hundreds of small, fragile glass tiles together, leading to massive labor costs and installations that can drag on for weeks. GAF engineered the Timberline system to be installed by the millions of standard roofers who already exist in every single city across America. The solar shingles simply overlap each other, instantly snapping their electrical connections together in a weatherproof housing as the roofer works their way across the roofline. From a financial perspective, this represents a masterclass in bundled economics. You are no longer hiring a roofing company and a solar company. You are hiring one crew, paying for one labor rate, and pulling one city permit. If your home is due, or even close to being due, for a new roof, the Timberline system combines a mandatory structural home maintenance project with a massive leap in energy independence. Number 2 is the SolarGaps Smart Blinds. One of the largest hidden inefficiencies of domestic architecture is the window. In a standard American home or apartment, windows are massive thermodynamic black holes. During the summer, intense solar radiation streams through the glass, creating a severe greenhouse effect that drives indoor temperatures sky high. To combat this, homeowners are forced to crank up their air conditioning units, spending hundreds of dollars a month running heavy compressors just to pump that heat back outside. Traditional solutions, like indoor curtains or static plastic blinds, only trap the heat inside the room after it has already breached the glass, offering little financial relief. But what if you could intercept those photons before they ever touch your window pane, and instead of letting them overheat your living space, convert them into usable household electricity? Enter the SolarGaps Smart Blinds. SolarGaps represents a total structural shift in how we view urban energy harvesting. Instead of looking up at a distant roof, this technology brings solar generation directly to the vertical facade of your windows. It is a highly kinetic, motorized exterior blind system where every single horizontal slat is built using high-efficiency monocrystalline solar cells, protected by a heavy-duty, weatherproof polymer coating designed to withstand severe storms, hail, and high winds. But the true engineering breakthrough here is the integration of robotics and automated dual-axis tracking. Traditional rooftop solar panels are entirely static. They are bolted down at a single, compromise angle, meaning they only achieve peak efficiency for a brief window when the sun passes directly overhead. SolarGaps rejects this limitation entirely. Inside the sleek header enclosure of the blinds sits an intelligent control unit equipped with integrated light sensors and positioning algorithms. Throughout the day, as the sun moves across the sky, a silent internal motor automatically ripples and tilts the entire array of slats in perfect unison. By continuously adjusting their physical angle, the blinds ensure that the solar cells are always facing the sun at a perfect 90-degree angle, maximizing photon absorption from sunrise to sunset. To an observer outside, the window facade behaves like a living, breathing robotic sculpture, subtly shifting its geometry as the day progresses. But the mechanical benefits translate directly into a massive double-sided financial return. First, by shading the exterior of the glass, SolarGaps acts as a highly effective thermal shield, blocking up to 85% of solar heat gain before it can enter the building. This immediately slashes a home's cooling and air conditioning energy consumption by up to 30%. Second, while the blinds are busy saving you energy on cooling, they are actively generating power. Around 10 square feet of SolarGaps, window coverage is capable of producing up to 100 to 150 watt-hours of raw electricity. That power is fed down a slim, hidden wire directly into a specialized indoor microinverter that plugs straight into your nearest wall outlet. Just like the balcony kits, this electricity instantly feeds your baseline household appliances in real time. Financially, a complete SolarGaps kit sits at a premium consumer tech price point, typically ranging between $2,000 and $4,000, depending on the specific dimensions of your home's windows. But because it attacks your utility bill from both sides simultaneously, massively lowering your cooling demand while actively generating grid-tied electricity, the real-world payback period is extremely impressive. Finally, at number 1 is the Smart Flower. The final and most visually spectacular solar innovation on our list addresses the most fundamental, unavoidable flaw of traditional rooftop arrays. They cannot move. When you bolt a standard rectangular solar panel flat against your roof, you are accepting a massive compromise in physics. The sun continuously moves across the sky from east to west, changing its vertical angle depending on the season. Because a roof-mounted panel is static, it only ever faces the sun at a perfect 90-degree angle for a few brief hours right in the middle of the day. For the entire morning and the entire late afternoon, the sunlight strikes the glass at an oblique angle, drastically reducing the amount of raw energy the silicon can actually harvest. The Smart Flower completely rejects this static limitation. It is not an appliance that you hide on your roof. It is a fully autonomous, robotic microgrid designed to sit proudly in your backyard. The visual impact of this machine is absolutely undeniable. At night, it rests as a sleek, armored, monolithic cabinet. But the moment the sun rises, the system wakes up and physically blossoms. A robotic arm unfurls a massive, circular array of dark blue, monocrystalline solar petals. Once fully deployed, the entire head of the machine begins to slowly, silently pivot, utilizing intelligent dual-axis tracking to lock onto the sun's exact position in the sky. As the sun arcs across the horizon, the Smart Flower follows it, tracking both vertically and horizontally. By maintaining a perfect 90-degree angle to the light from dawn until dusk, this kinetic geometry allows the Smart Flower to generate up to 40% more electricity than a static rooftop array of the exact same size. But the engineering genius of the Smart Flower extends far beyond its ability to move. It actively solves the two silent killers of solar efficiency: heat and dirt. Standard rooftop panels sit just inches above scorching hot asphalt, baking in the radiant heat, which severely chokes their electrical output. The Smart Flower is suspended entirely in the open air. The ambient breeze passes freely behind and between the individual petals, providing passive air cooling that keeps the silicon operating at peak thermal efficiency even in the dead of summer. On top of that, every single time the Smart Flower folds itself up at night and unfolds in the morning, a series of specialized brushes mounted on the back of the petals sweep across the face of the glass below them. It sweeps away dust, pollen, and snow before they can block the photons, ensuring absolute maximum yield day after day, without you ever having to climb a ladder with a squeegee. Mechanically, it also addresses the danger of severe weather. Just like traditional horizontal wind turbines, solar panels are highly vulnerable to catastrophic storm damage. The Smart Flower is equipped with a built-in anemometer that constantly monitors the local wind speed. If a severe gale rolls into your neighborhood and the wind crosses a dangerous threshold, the system does not wait for human intervention. It automatically folds its delicate petals back into its heavily armored, steel-reinforced base, securing itself until the storm passes. Financially, the Smart Flower sits at the absolute premium luxury tier of the residential energy market, requiring a significant capital investment. However, its value proposition is built on completely bypassing the agonizing soft costs of traditional solar. There are no roofers tearing into your shingles. There are no structural engineers analyzing your rafters, and there is no massive metal racking system to construct. The Smart Flower arrives as a completely self-contained, plug-and-play unit. A technician simply bolts the base to a small concrete pad in your yard, connects the integrated inverter to your home's electrical trench, and the system is instantly online. If you ever decide to move to a new house, you don't have to leave a $30,000 solar array behind on the roof. You simply fold up the smart flower, unbolt it, and take your power plant with you. It is the ultimate convergence of biomimicry, robotics, and clean energy. It proves that when we stop treating solar power as a static piece of building material and start engineering it to actively interact with the solar system, we can squeeze unparalleled amounts of raw energy out of our own backyards. The blue rectangle bolted flat to your roof is no longer the only way to harvest the sun. Whatever obstacle stands between you and energy independence, brutal summer heat that chokes a standard array, an aging roof that ruins the financial math, a rented apartment with no roof access, or the soft costs of electricians and permits, there is now a system engineered specifically to get around it. The future of home solar looks bright, and these remarkable innovations prove it. If you enjoyed this video and want to discover more tech at the forefront of home energy independence, then make sure to take a look at our video on the 6 most innovative home wind turbines on the market right now.